In this video, we will discuss and demonstrate the model transform from an NX assembly model to a Rhapsody SysML model, including compare and sync functionality. The normal use case is that a CAD designer has created a CAD model of a new assembly and wants to create a SysML block with part properties corresponding to the CAD assembly parts and value properties corresponding to assembly mass properties. These properties could be used to check the current design against requirements. The designer also wants to be able to update the SysML model when the CAD design changes so that the SysML model reflects the latest design. As preconditions, the Syndea user needs first an NX license and second the NX interface module for Syndea. An NX license is required because, as with all the other Syndea interfaces, Syndea has no access to system data unless the user does. See the Syndea user guide for more information about the NX installation requirements. For this example, we have created a simple CAD assembly for some of the mechanical components of a cell phone, including the front, internal, and rear casings, and the main PCB. This design has been saved on my local drive. I have also created a Rhapsody model with an empty package called Case. This will be the destination of the CAD model transform. Notice that the SysML model already contains the Syndea profile. We will launch Syndea from the Case package and go first to the Settings tab. Scrolling down to the NX heading, we first make sure that the top two boxes are unchecked. If they are checked, uncheck them, click Apply, and close the Syndea dashboard and then reopen it. Unchecking them means that the NX part features will not be carried over into the SysML model. Remember that NX 3D CAD models build up shapes from features like extrusions, rotations, and the like. We can bring those features over into the SysML model as part of the block structure, but there is typically not much reason to. The Team Center tier type settings is important when the NX CAD file is being configuration managed and accessed in a Team Center PLM repository. We will not be demonstrating that scenario in this video, but will note that such access requires both the Team Center and NX Syndea interfaces to be available. As usual, going to the Connection Manager tab, we open the repository link on the right side to our local file system and find the phone model in the CAD file. Note that this is the element with the assembly icon, not the part file of the same name directly above it. We set the center column to Model Transform and drag Assembly 1 into the Case package. Very shortly, we see the part structure of the assembly on the SysML side. If we expand the Assembly 1 block, we see that it contains 4 part properties corresponding to the 4 parts of the assembly, plus several value properties reflecting the mass properties of the assembly. Mass properties include mass, volume, density, surface area, and also the coordinates for the bounding box around the assembly. Mass properties are calculated by NX for a part or assembly of parts, and Syndea brings them over to SysML in the model transform. Back in the Rhapsody tool, we have created a block definition diagram and drag Assembly 1 block into it. Where the value and association and properties are displayed. If we also drag out the internal enclosure part property into the diagram, it shows up as a separate block connected to Assembly 1 by a white diamond or directed aggregation arrow. Both blocks have the NX part stereotype. Going to the browser and looking under Associations, we also see an additional component called internal enclosure, and we can display that in the diagram. The new block appears as an association block. It also has the name internal enclosure, but it has the NX component stereotype, and its value properties are the translation and rotation matrix coordinates that represent the part position within the assembly. We can make the appearance of the association block more standard by removing this line from view and adding an anchor to connect the association block with the association. This approach uses the SysML concept of association block to hold the additional geometric information to fully specify the assembly. Going to the Connection Summary tab, we see the 5 new connections that are being maintained by Syndea between the CAD and SysML models, one for the assembly and each of the 4 parts. We can use these connections to compare and sync models. If we right-click the assembly connection and choose Compare, the result is all green. Neither model has changed since the initial model transform. Now we will go and modify the CAD model. I choose the internal enclosure part, deepen the part, and thicken the shell. Then save the model in NX and return to the Syndea dashboard. Now we compare across the connection for the internal enclosure and we see the changes in several of the mass properties, including mass, surface area, volume, and the height of the part. We can also see changes to some of the mass properties of the overall assembly, because of the changes to one of its parts. To update the internal enclosure part mass properties, we go back to the connection browser, click the connection for internal enclosure, and choose Sync Target to SysML. Now when we compare, we see that the models have been reconciled for the internal enclosure part. However, they have not been reconciled for the assembly. And we must repeat the process for the assembly connection as well. Which has now been reconciled separately. Even though the mass properties of the part and the assembly are linked in the CAD tool, the corresponding value properties are not linked in the SysML model, and therefore they must be updated separately. However, we can update across all connections by updating from the case package row in the connection browser. For the SysML NX connection, the Sync SysML to Target reverse update has no effect. NX mass properties are calculated values and read-only, and they cannot be updated from the SysML model. Also, the CAD designer will probably not want the system engineer modifying the part dimensions remotely in any case. However, there is a use case where the system engineer may want to send geometric information from SysML to CAD in specifying requirements for reference planes, bounding boxes, or keep-out zones as CAD features. This will be the topic of the video demonstration 13.2.